Here we are at example C from our 0.1 number 27 notes. We're asked to solve now this following equation. The reason why I mention equation is because, well, there's simply an equal sign. Okay? And as a result, anytime you're trying to solve for something, especially in this class, you're going to have a variable on one side. So in this case, we notice that there's x's equals some number or something. Okay, it doesn't matter which side the x is on. You could have x equals some number over here. You could have the number on this side equals x. As long as you have x all by himself equals something. Nothing can be around the x or whatever variable you're trying to go for. All right, now let's see C in action. This is kind of, again, our end game. And just looking at this, if we were just to kind of focus on the left side for right now, so we'll kind of just draw a little line through this, and just focusing on this left side. We have 1 plus 2, and then parentheses x minus 1. Well, we know that we can go ahead and distribute the positive 2. So we have our 1 in front, plus 2 times x gives us 2x. And 2 times negative 1 gives us negative 2. So again, the only thing we did there was really just focus on the left side. Can we combine anything on the left side? In other words, are there numbers that we can go ahead and bring together? There totally are, this 1 and this negative 2. So 1 plus negative 2, or 1 minus 2, comes out to be negative 1 plus 2x. Now, unfortunately, we cannot do anything else on this left side. So what we're going to have to do now is go ahead and look at things on the right side of the equation. Looking at the things on the right side, we notice that we have this 4 minus and then this parentheses. Really, there is that hidden negative 1 in front. And that's what we're going to go ahead and distribute, the negative 1. So we have our 4. Negative 1 times positive 2x gives us negative 2x. And then negative 1 times positive 3 gives us negative 3. Again, distributing, we're multiplying those. Again, just looking at things on the right side, is there anything that we can combine? There absolutely are. This 4 and this negative 3. So 4 plus a negative 3 gives us regular positive 1 minus 2x. Now, all throughout this time, there actually have been, between the purple and the red lines, we actually still have had our equal sign. So that thing is still kind of just carrying down. That's what separates the left side from the right side instead of that squiggly line I just had. Now again, our end game is to try and figure out what x is, but what we did was we simplified each version as much as possible on both sides. Now these two look a lot alike, but they're actually a little bit different. Generally, I like to keep my variables, so this guy and this guy, positive. You don't have to, but it will make your life easier. And what I mean by that is the coefficient being positive. So how do we make the coefficient positive? Well, I have a positive 2x here, and I have a negative 2x over here. If I were to add 2x to both sides, because remember what you do to one side, you have to do the other. That's how we help balance these equations. What you do to one side, you have to do the other. If I added 2x to both sides, then we end up with this negative 1 still. And then 2x plus another 2x gives us 4x. Equals, on the right side of the equal sign, we end up with 1. And we notice that over here, these just cancel. You have negative 2x plus 2x. That should happen. That's fine. But notice how our variable 4x is a positive 4x. Trust me when I say that does make your life a little bit easier when you're working on problems. Again, your variable coefficient should be positive. Or at least it shouldn't. It doesn't have to be, but it will make your life easier. Now again, we want to isolate x, so we need to get everything that's not associated with x onto the other side. So we're going to go ahead and add this 1 over to both sides. Again, what we do to one side, we have to do the other. Negative 1 plus 1 cancel out, leaving us the 4x equals 1 plus 1 gives us 2. And then lastly, we have 4 times x. Well, that 4 is stuck and glued to x, so one thing that we have to do to get it unstuck is go ahead and divide 4 on both sides. Because again, this is 4 times x. If we divide both sides by 4, it will get rid of that. Because any number divided by itself is then just 1x. And that's what we care about, just having x, one of them. So then we end up with x equals 2 divided by 4, but you do need to simplify that answer. So 2 divided by 4 is the same thing as saying 1/2. This then would be our final solved version of it. If, for example, you had x equals 1/2, that's totally cool too. Okay. Now, if you had, in fact, right here, subtracted 2x from both sides, the only thing that would have been really different you would have had negative 2 over here, and you can try this kind of on your own. And then over here, we would have had negative 4x. Okay. So if you had subtracted 2x from both sides, and then from there you would have divided that coefficient just like we did right here. These would have canceled. Negative divided by a negative becomes the positive version then. So again, if you're balancing equations, you can do either side. It just really helps to keep your coefficient positive in front of that variable. Okay? And that way you don't have to worry about all these like negatives and stuff. What are the differences? It's just a little math strategy. What are the differences? Well, evaluating. A lot of times evaluating just pretty much deals with substitution. Not every time, there's other stuff too. But that's pretty much what you do with evaluating. So evaluating oftentimes has like a substitution move. Not every time, okay? In terms of simplifying, that's where we're really trying to condense it as much as possible. Now, that doesn't necessarily mean, though, that like you end up with just a final answer, like 7 or 2. Like we ended up with a variable, I think it was like negative 9x plus 5. Okay, so you can end up with more stuff than just maybe a number. And then solving is where we actually end up with a variable. It's not always x, it could be like radius r, but it's some variable, or y, that equals something. Usually it's a number. It's not always a number. So I'm just going to say something. When you guys go into higher math, you'll see that it can be other stuff. For the sake of this course, it's dominantly going to be, though, a number. And actually, I'm sorry, when we get to systems, it'll be maybe variables too, but for right now, this is fine. So again, evaluating a lot of times calls for substitution, simplifying. You're breaking it down as much as possible, solving like a variable equals something. Now, a lot of times, one last thing, a lot of times when you're trying to solve for something, you may end up having to use simplifying. Okay, that actually happens quite a bit. A lot of times you're actually simplifying within the problem to actually then finally solve the problem. This was a prime example right here. When we had 4x, and we divided 4 on both sides, we ended up then with x equal 2 over 4. Well, right here we simplified it to get a half. Okay, so simplifying can happen within solving. But if you're trying to simplify something, then that's it. You're not solving it. All right. So again, though, that is example C from our 0.1 number 2 set of notes.